السلام عليكم. إذا راح نحل بعض المسائل في section 2.2 وتحديدا الانفرسز. الموضوع في غاية الأهمية يعني ونحل بعض المسائل. Let's start. We will solve sample questions. So for example الأسئلة من 1 ل 4 we will solve one of them, just one of them. Find the inverses of the matrices. So we are given some matrices. For example this one, so number 4. I have a matrix A that is equal to 3 minus 2, 7 minus 4, and the question asks about the inverse of the matrix. The inverse of the matrix. Now this is a 2 by 2 matrix. So now we remember, if we have a 2 by 2 matrix A, B, C, D, how do we find the inverse? It's 1 over the determinant multiplied with, as we agreed, the main diagonal is flipped and the other diagonal is negative the sign. And at this moment we just need to recall that to apply this formula, this number, which is called the determinant of A, which is AD minus BC, this should not be 0. If it's 0, the matrix is not invertible. So the first thing in these equations, we check the determinant. So now in this equation we check the determinant. What is the determinant of this matrix? It's 3 times minus 4, that's minus 12, minus 7 with minus 2, that's minus 14. So basically this is minus 12 plus 14, this is 2. Now the 2 is not 0, this means the matrix is invertible. If it's invertible, then we can solve it. How do we solve? How to find the inverse? It's 1 over 2, the determinant, then have the determinant, 1 over 2, times, the diagonal is flipped, so minus 4 with 3, the other diagonal we change the sign, and that's it. And we do all the questions in a similar way. And then this is how we find the inverse of the matrix. For the second question, verify that the inverse you found is correct. What do we mean by this question? We mean, for example, in number 4 again, so I have the matrix 3, negative 2, 7, negative 4. We found the inverse to be half, negative 4, 2, negative 7, 3. How do we verify if our answer is correct? We multiply the two. That's why I multiplied the two matrices. I must get the identity. So the question now, do we get the identity? If we get the identity, the solution is correct. If we don't, it's not. So first of all, the half, I can write it just away, like this. And then we multiply. We multiply the row, this row, with this column. I'm not going to write the details, but 3 times negative 4, that's negative 12, plus 14, that's 2. 3 times 2, 6, minus 6, that's 0. 7 with negative 4, this will be 0. 14 minus 12, this will be 2. And because it's multiplied with half, it will be 1, 0, 0, 1. And this is exactly the identity, so we are okay. So in general, just remember this. In general, how do we know if a matrix A is the inverse of another matrix B? I need to multiply them and we get the identity. You get the identity, then I conclude B is A inverse. You don't get the identity, it's not the inverse. So this is for the first set of questions. I'm going to delete the solution for 2 reasons. For the space I have and for you to practice. But this is how we solve. Okay, now let's move to question number 7. Question number 7. And this covers a main idea in this section, which is use the inverse you found. So in the first exercises from 1 to 4, we found some inverses. Now we want to use these inverses, the استعمل هاي الانverses, to solve systems. To solve the systems. So here I need to recall something. So for question 7, I need to recall something. How do we solve Ax equals B? How do we solve this? I can solve this by row operations. So I write the augmented matrix and we do all the details. هذا الشيء عملناه بالتفصيل. The other idea, we can use the inverse. But to use the inverse, I have some restrictions. The matrix A must be square. Not only that, but also the matrix A must be invertible. So if the matrix A was invertible, in that case I can solve the system by saying X equals A inverse times B. This is like an easy way to solve systems, but again, this requires the system to be square. What do you mean by square system? We mean number of equations equals number of variables. Also, the matrix of coefficients or the coefficients matrix has to be invertible. So if you look at question number 7, what is the coefficient matrix? It's 8, 3, 5, 2. What is the B? It's 2, -1. Now, can we solve the system using the inverse? This depends on whether A has an inverse. If A has an inverse, we can. So how do we check that? We compute the determinant, which is 8 times 2 minus 3 times, that's 1. And because the determinant is not 0, A inverse exists. How do we find A inverse? Remember, we divide by the determinant, but the determinant is 1, so this is 1 over 1. On the diagonal, we flip the interest. On the other diagonal, we change the signs. This is A inverse. Now, once we have A inverse, I can write the solution from this formula, which is, so now the solution X is A inverse B. What does it mean? It means this matrix multiplied with B. Now B is 2, -1. And we just multiply them. So 2 with 2, 4, plus 3, 7, minus 10, minus 18. So this is the solution of the system. This is the solution of the system. That means x1 is 7, x2 is minus 18. This is the solution of the system. And the same thing you can do for the next exercise. So the main idea here is that we can use the inverse to solve linear systems, but we have some restrictions that the system has to be a square system and the coefficient matrix has to be invertible. Now, of course, we can solve using the old method, which is row operations, to verify our solution, or you can substitute them into the equations to verify it is a solution. Okay. نمسح المكتوب. نطلع على السؤال التاسع. I have a matrix A and the question says find A inverse. So quickly, what is A inverse? First of all, does it have an inverse? We multiply 12 minus 10, yes. This is the 1 over the determinant. On the diagonal, we flip. On the other diagonal, we change the signs. This is the inverse. Now the question says use this to solve the 4 equations ax equals b1, ax equals b2. So let's solve any of them. For example, how do we solve ax equals b1? X is A inverse b1, that's it. What about ax equals p2? X is a b2, that's it. So you multiply A inverse is this times what is b1? It's -1, 3, and you multiply them. So this is minus 12, minus 6, that's minus 18. 5 plus 3, that's 8. All of this is multiplied with half. So this is -9, 4. This is the solution. Okay, so it's a simple one. Okay. Now, of course, we can solve the system. We can solve this system as an augmented matrix. Remember, we can write, so the alternative solution, we can write 1, 2, 5, 12. This is the coefficient matrix. And beside it, we can write B1, which is -1, 3. But here, just what is the comment here? Look, if you want to solve the system AX equals B1, this is the augmented matrix. This is B1. This is B1. If you want to solve the system AX equals B2, you write the augmented matrix. What's the augmented matrix? You write A, and beside it B2. So you can write B2 together like this. B3, you can write it 2, 6 like this. B4, 3, 5 like this. Okay? And this is like a big augmented matrix. This is a big augmented matrix. Now, if you apply the row operations, you will reach something like this. And you get something here, something here, something here. Now, the point is, this will be the solution of AX equals B1. This will be the solution of AX equals B2, AX equals B3, AX equals B4. So this is just a comment that you can solve these systems in one step as one augmented matrix. Okay. So it's very important now to just remember that we can solve systems using two methods: the row operation method, the classical method, let me say, and the inverse method. But for the inverse method, we have some restrictions. The matrix has to be square, and it has to be invertible. Okay. Now we have some true or false questions. In order for a matrix B to be the inverse of A, both equations must be true. So A, B, it has to be equal to B, A, it has to be equal to the identity. So the question says, for a matrix B to be the inverse of A, both equations have to be true. Yes, and this is the definition. And by the way, now here there's a little confusion that are these matrices square matrices or not? Look, this is an n by n matrix. Now, if you multiply A with B, you must have n multiplied, something multiplied, okay? And here you must have n, sorry, like this. So to obtain in both directions a square matrix, you must have n. I mean, we must have square matrices. So for the question 11, this is yes, correct. Okay. A product of invertible. So I have invertible matrices. The question says the product of invertible n by n matrices is invertible. That means the following. Imagine you have a matrix A, square matrix, another matrix B, square matrix, and both are invertible, which means A inverse exists, B inverse exists. So both exist. The question says a product of invertible matrices is invertible. So is the product, is this invertible? So if you have two matrices, so we are talking about question 12. If we have two matrices, both of them are invertible. Is the product invertible? Yes, this is correct. Let's continue. And the inverse of the product is the product of their inverses in the same order. We need to understand the question. So please, again, this question has two things. The first part of the question is correct. The product of invertible matrices is invertible, yes. Let's continue. And the inverse of the product, so A, B, inverse. This is the inverse of the product, is the product of their inverses in the same order. The product of their inverses in the same order is this. Is this correct? No. We know from class that A, B inverse, لما نوجد الانفرس الحاصل الضرب, we reverse the orientation, we reverse the direction, the multiplication, the order. So in this case, is the statement true or false? It is false. Okay, the first part was correct, but then if you continue, it has a wrong argument, which means the statement as a whole is a wrong statement. It's false. Let's continue. If A and B are n by n matrices, then and invertible. So A and B are invertible matrices, then A inverse B inverse is the inverse of AB. Okay, so I have two invertible matrices. So A and B are invertible. What does it mean? It means A inverse and B inverse exist. So I have matrices that are the inverses. Then the question says A inverse B inverse is the inverse of AB, like this. Is this correct? Again, this is wrong. لأنه A B inverse is B inverse A inverse. So this is false. If A is invertible, then the inverse, okay. So A, this is question 14. A is invertible. That means A inverse exists. The inverse of A inverse. So the inverse of A inverse, what is this? This is A? Yes, this is correct. The inverse of the inverse goes back to the original matrix. These questions, they help us understand the concepts, the true and false questions. They help a lot. If A, so we have a 2 by 2 matrix, and AB minus CD is not 0, then A is inverted. What do you think? Okay, false or true? This is false. Why? This minus this should not be 0. If AD minus BC was not 0, then the matrix is invertible. But look here, it's AB minus CD. It's wrong. It's AD minus CD. And in these cases, it's good to have an example, by the way. It's good to have an example like 1, 6, 2, 3, for example. Look, this matrix is invertible. Why? Because 1 times 3, maybe this example doesn't work, by the way. AB minus CD is not 0. Okay. So 1, 2, 2, 4, like this. Look, this matrix is not invertible. Why is it not invertible? Because this minus this is 0. Okay? Let's look at the statement. If you calculate A times B, what is A times B? You multiply these, minus you multiply these. So you multiply 1 times 2, minus 2 times 4. This is what? This is not 0. But is the matrix invertible? No. So this example confutes the statement. So we have the example where this is not 0, but the matrix is not inverted. So this is false. Okay. If A equals and AD, which is this, equals BC, then A is not invertible. Of course, this is correct. Why? لأنه إذا AD minus BC equals 0, that means, if AD equals BC, that means AD minus BC equals 0. This means the determinant is 0, which means the matrix is not invertible. Again, these examples, they summarize everything. They summarize everything. They test our understanding. Okay. Question 17. If A is invertible, okay, then the equation is consistent. So I have AX equals B. I know that A is invertible. The question says, given these information, the system is consistent. Is consistent. It's always consistent. Is this correct? Let's think a little. Is it correct? Yes. Why is it yes? Because we know X equals, we just talked about this. X equals A inverse B. If the matrix was invertible, I can solve any system. Okay? If A can be row reduced to the identity matrix, then A must be invertible. What do you think? So if you have a matrix that you reduce and you get the identity, it is invertible. Exactly, yes. Because this is what we mean. This is the algorithm. This is the algorithm for finding the inverse. To find the inverse, you start with A, you write I, you reduce. If you reach I, then this will be A inverse. If you cannot reach I, you cannot reach A inverse. Okay? So this is the criteria. This is how we tell for now if the matrix is inverted or not. Each elementary matrix is inverted. Remember, what do we mean by elementary matrices? It's a matrix that results through one row operation from the identity. And yes, this is invertible because E inverse is we reverse the row operation. This is true. If A is invertible, then the elementary row operations that reduce A to the identity also reduce A inverse to IN. What is the meaning of this? So let's read the question again. If A is invertible, okay, then the elementary row operations that reduce A to the identity. Let's recall this. I have A with I apply row operations to reach I and A inverse. So here you apply a sequence of row operations. from A to I, you apply a sequence of row operations. Now the question says, these row operations are, they are the same that reduce reduce A inverse to IN. So these row operations are the same row operations that go back from A inverse to I. This is wrong. This is wrong. Why? Because we need to take the inverses, the inverse row operations. For example, if from A to I, if you apply the row operation to R1, when you go back, you must apply half R1. Okay, these are the inverse elementary matrices. Okay, so so this statement is wrong. This statement is wrong. Okay. Let's see like this. We have three matrices, A, B, C. So I have AB equals AC. B and C are n by P. So C is n by P, P is n by P. And A is invertible. So A is a square matrix that's invertible. A inverse exists. Now the question says, show that B equals C. Now, what is the moral of this question? What is the moral of this question? We said that in matrices, if you have the equation AB equals AC, this does not mean in general B equals C. Okay? This is not true in general. Again, this is not true in general. However, if the matrix A was invertible, this is correct. Okay? How is it correct? Because if AB was equal to AC and A inverse exists, then I can multiply this equation by A inverse. And it's very important that when you multiply from left, not from right, from left. Why? Because A inverse times A is the identity. A inverse times A is the identity. And the identity times B is B. The identity times C is C. So this is the proof. This is the proof why if AB equals AC and A was invertible, then B would be equal to C. Now of course we are running fast. يعني أنا بحل بشكل سريع حتى نحل أكبر عدد ممكن من المسائل. يعني after all أنت بتقدر تعمل بوز للفيديو وتركز بالحل زيادة أو تبطئ أو whatever. بس الفكرة الآن إنه إحنا هدفنا نحل أكبر عدد ممكن من المسائل. Suppose B minus C. So we have three matrices again, B, C, and D. B minus C times D is 0. The question says D is invertible. D is invertible. Show that B equals C. So D is invertible. I want to show that B equals C. How do we do that? I have this. Because D is invertible, it has an inverse. So I multiply this equation from this side by D inverse. What do we mean by from this side? I mean like this. D times D inverse is the identity, and 0 times is 0. But anything times the identity is the same thing. And if you move this, you get B equals C. So this is the proof. So again, when the matrix is invertible, you can multiply with the inverse. You can multiply with the inverse. If it's not invertible, you can't. So it's very crucial. What about a question like 25? I have three invertible matrices. Show that ABC is also invertible. Ooh. ABC is also invertible. Okay, I have A, B, and C invertible. That means A inverse, B inverse, and C inverse exist. Each one of them exists. Now the question says, show that A, B, C. So what we want is A, B, C is invertible. What do we mean by a matrix being invertible? Any matrix is invertible if you can multiply it with something to get the identity. So let's think together. What is the matrix that you multiply with this and you get the identity? Look, the C must be multiplied with C inverse, because if you multiply C with C inverse, they will be cancelled. Then you will need to multiply B with B inverse, then you multiply A with A inverse. Now look, let's multiply them. C with C inverse, that's the identity. So this becomes AB times the identity, B inverse, A inverse, equals. But B times the identity is B. So AB, B inverse, A inverse. Now B inverse is the identity. So this is A, identity, A inverse. But A times I is A again. So this is A times A inverse, which is I. Okay? So this is it. Very simple ideas. Very simple ideas, but we need to understand the concept. So just remember this. Remember this. What is that? Here is this. So all the time, if you want to show that something is the inverse of something else, so you have, let's say, a matrix A, another matrix B, and you want to explain why this is the inverse of this, you multiply them. If you get the identity, then one of them is the inverse of the other. Okay? All the time. Now for this question, it's just the idea. If you have A, B, C inverse, you distribute this, but you reverse the order. So it's not A, it's not this. This is wrong. It is this, but in the reverse order. So C inverse, B inverse, A inverse. Okay. Let's look at question 27. Let's look at question 27, sorry. Solve the equation for A. So I have AB equals BC. The question says solve it for, what do you mean by solve it for A? It means find A. What is A equal to? Assuming that B is invertible. So A, B, C are square matrices and B is invertible. Why is this information important? Because then I can multiply with the inverse. So now the question, do we multiply from here by B inverse or from here by B inverse? Okay, look, if you multiply from this side, you will get B inverse A, B. If you multiply from the other side, you get A, B, B inverse, and this gives you the identity. So I will multiply from this side. This is how we decide. So we can simplify. Then I multiply from the right. In this case, it becomes AB, B inverse equals BC, B inverse. B with B inverse, they get cancelled with the identity, and this is A. Okay, this is A. Let's see 28. I have A equals P, B, B, P inverse. I want B. How do we find B? Look, you want B. So you multiply from this side by P, from this side by P inverse. Why? Let's do it. So from left, you multiply with P inverse, from right with P. From left by P inverse, from right by P. Why? Because P inverse times P is the identity, and this is the identity. So on the right, you'll be left with B equals P inverse. This is B. So we are solving equations using the inverse. Very nice questions. Simple ideas, very simple ideas. It all depends on our understanding. A, B, C are invertible matrices, and we are talking about the system. So we have C inverse A plus X, B inverse equals I. The question says, does this have a solution X? So can we find X? Yes, of course. Look, I multiply from the left by C, I multiply from the right by B, because then the left side becomes, the right side becomes like this. C with C inverse, they cancel, A plus X equals CB, so X is CB minus A. That's it. I think now the idea, I think it's clear. It's very simple. Okay. Explain why the columns of a square matrix are linearly independent when A is invertible. إذا الماتريكس invertible بدي أبين إن الcolumns are linearly independent. Okay. I have a matrix A that's invertible. What does it mean to say no A is invertible? It means if you reduce A by row operations, you will reach the identity. What do you mean by the identity? It's something like this. Just imagine the identity. When you talk about the identity, all rows have a leading one, all columns have leading ones. This means that all columns of A are linearly independent, because that's how we check columns for being linearly independent. Okay, if all columns are pivot columns, they are independent, and this is our case. That's it. This is it. Then, because the matrix is invertible, it can be reduced to the identity, but in the identity, all columns are pivot columns, and that's it. Okay, now as a last example, for this short video, we want to find the inverse of these matrices. For the 2 by 2 matrices, we have the formula, but we want to use the algorithm. What algorithm? I mean, we write the matrix augmented with the identity, and we start the reduction. So minus 4R1 plus R2. Then minus R2. Remember, I'm trying to get the identity in this part of the matrix. Then minus 2 R2 plus R1. That's it. This is the inverse matrix. Then A inverse is 7. Is it 7? Minus 7. 2 and 4 negative 1. Yeah? That's it. For a 3 by 3 matrix, it's the same thing exactly. So we will solve one more example, and that's it. For example, this one, I have the matrix 1, negative 2, 1, 4, negative 7, 3, minus 2, 6, minus 4, augmented with the identity, and start the reduction. So the first row operation, I have 1. I want everything below it to be 0. So minus 4R1 plus R2, 2R1 plus R3. So minus 4, 1, minus 1, minus 4, 1, 0, and 2, 0, 2, 2, 2, 2, seems 2, 0, 1, like this. After that, I have this one, so I want above it 0, below it 0. So 2R2 plus R1 minus 2R2 plus R3. Two R2 plus, so this is 1, this is 0, minus 1, minus 7, 2, 0, and minus 2, this is 0, this is 0, this is 4, this is 10, this is minus 2, this is 1, and after that I want this to be 1 quarter R3, and 1 0 2 7 2 0. So these questions are about calculations, nothing, no ideas. And after that, we just apply. We want this to be 0 and this to be 0, and that gets this. The result will be the inverse. So I want 3 over 4 R1 plus, R3 plus R2, and 3 over 4 R3 plus R1. We do the calculations, and here we'll have the identity. Here we will have the inverse. And again, sorry for being fast, but I wanted to solve as many examples, and we did great. We solved almost all the questions. Now for you need to practice the other questions, like how to find the inverse, we missed some questions, like I think this one we did not solve it, this one we did not solve it. So you need to practice these questions, okay? And I hope I will be able to make another video on the LU factorization. Assalamu alaikum.